Dear students, welcome to my channel. Today I am going to explain about that max heap deletion and min heap deletion. We will going to explain here each and every step while performing the deletion. So suppose here I am going to delete, this is already given is that max heap. So here I am going to perform deletion on the max heap. So this is already max heap. Now I am going to delete the maximum element. If I'm going to delete the maximum element, so what is the, we already know that in max heap the parents should be always greater than equal to children. Parents should be always greater than equal to children. It means that the root will be the maximum of all the children. So if I'm going to delete the max, if I say that delete max, if I say that delete max, then what element will you delete? That 10 is going to delete. So here a step is given, that you can say that the algorithm of deletion is given. What it is saying, that replace the element to be deleted. The replace the element to be deleted. Here I am going to delete the max element, and max is nothing but a 10. And what it is saying, that replace the element to be deleted by the last element and delete the last element of the heap. So first step is going to do that replacement. So first we will going to do what? Replace. Step 2, what we will going to do? After the replacement we will going to perform delete. The last element we will going to delete. The last element we will going to delete. Step 3, what we will going to do? Then in third step we will going to perform heapify. We will going to perform heapify. This heapify I have already explained the previous video. So please watch the previous video for understanding the heapify, from which node onwards we will going to perform heapify. So I have explained in already everything in the previous video. So here if I am going to delete the 10, if I am going to delete the 10, first statement what it is saying, that replace it. So replace with the last element, replace the element with the last element. So what is my last element? My last element is 7. So 10 is going to replace by 7. 10 is replaced, and we can say that the swap by 7. So 10 come here, and this is going to delete it. This is now become 7, and this 10 is deleted. Second step, what it is saying, that the deleted. So this last element is deleted. Third step, we have to check that after the maximum element deleted, suppose 10 is deleted here, then check that it is still max heap, because you have deleted maximum element and you are working on the max heap. So you have to, after the deletion operation, you have to check that still your tree is following max heap property or not. So if you observe here, so now 7 is become the root. Now tell me, is 7 greater than their children, greater than or equal to children? 7 children is now 8 and 9. Is 7 greater than 8 and 9? So no, this is not following the max heap property. Then what will you do now? So you have to perform heapify here. You have to perform heapify here, because you have already given tree and you are performing deletion operation, and after the deletion you have seen that this tree is not following the max heap property. Then what will you going to do? That you have to perform heapify, and from which node onwards you are going to perform heapify? I have already said that in the previous video, you always perform a non-leaf node that is stored at largest index. So if you see that the index, this is 1, this is 2, this is 3, this is 4, this is 5, right? So this is non-leaf node, this is this is leaf node, this is leaf node, and this 7 is already deleted, and because of this deleted, so 9 is also become leaf node. So you have only now two non-leaf node, that is 10 and 8. So afterward what you will get, that the new tree you will get that here 7, this is 8, this is 9, and this is 5, and this is 2. Now tell me, from which node onwards you will going to perform heapify? So here I have said that this index is 0, this is 1, this is 2, this is 3, this is 4. So what will you do here? You have to perform heapify for this tree. This part you have to perform heapify. You have to perform heapify here. So you have to check that is 8 greater than with their children. So 8 children is 5 and 2. 8 is greater than 5 and 2. Yes, it's greater. So it's already following the maxi property. It's already following. Now what will you do? You have to check that is 7 greater than 8 and 9. So no, this is not following. Then what will you do here? You have to take the maximum of 8 and 9. If you take the maximum of 8 and 9, you will get that 9. So this is going to swap with 9 and this 7 will come here. Right, 7 will come here. So afterward, after this operation, you have to check that is it following the maxi property. So now check that 9 children is 8 and 7. Is it following? Yes, it's following, and here also following. So after the complete deletion, you will get the final tree is this one. So this is your final tree after the deletion of the 10. Similar like the 10 you have deleted again and again. If you see that this is max heap. Again this is max heap, and again if I ask you to delete the max, if I ask you to delete again max, so what will you do? You have to delete 9, and 9 is replaced with what? If you delete 9, then you have to replace with some value, na? So can it will be 3. So 9 is deleted, so 9 is going to replace with the last node. So what is the last node? Don't say the 7 is the last node. No, 7 is not the last node. Here 2 is the last node. Here 2 is the last node, because in the complete binary tree, if you are going to store the element in the array, it always going to store level wise. Level wise it is going to store. So your last element is 2. This is fourth index. The last element is 2. So 9 is going to replace by 2. So 9 is here, I'm saying that delete the element. So 9 is going to here replace by 2. So you will get this tree. So 9 is replaced by 2, and 2 came there and 9 came there, and now what will you do? You have to delete that 9. After the swapping, you have to delete the last element. So after the deletion, you will get this tree. After the deletion, after this 9 is deleted, you will get this tree. Now you check that what you are doing, you are performing deletion operation on max heap. So what you will do, you have to check that is it following the property of the max heap or not. Is it following the property of the max heap or not? So see that root is here 2. 2's children is 8 and 9. Is it following the maxi property? No, this is not following the maxi property. Then what will you do? You have to perform here heapify. You have to perform heapify. And heapify, I have already said that you always start from non-leaf node. You always start from a non-leaf node largest index. So what is the largest index here? 0, this is 1, this is 2, this is 3, and this is deleted. So this 9 is deleted. So now this is not there, right? So this is leaf node here. 7 is also leaf node. So you have non-leaf node is 8 as well as 2. You have non-leaf node is 8 and 2. So what do you have to do? Perform heapify. Start from here. So check that is it greater than, it is greater than equal to 5. Yes, condition true. Then what will you do? Come here. Here you check that is 2 greater than, is 2 root node is greater than 8 and 7. No, this is not true. Then what will you do? You have to take maximum of 8 and 7. If you have to take maximum of 8 and 7, so what is the maximum value? Maximum value is 8. So if this 2 is going to replace by 8, and this 2 will come here. But still if you see that, you have to see that 8 became root. Now still this is not following the maxi property. Then what you have to do? Again perform this swapping here. So 2 will come here now, and this is become now 5. After this heapify operation, you will get, this is the final tree, you will get that, and this is max heap. This is max heap, right? If I say that again delete max, if I say that again delete maximum element, we know that always the maximum element on the root node. We already know that the main max heap parent should be greater than children, greater than equal to children. So if you delete the maximum, it means that you have to delete the root element. If I say that random element to delete, you can delete. The process is still same. The process is still same. But in the, if I say that delete the max, you have to delete always root element, because maximum is always on root. If same thing if I do in the main heap, if I say that delete main, it means that minimum element always on the root node. So for delete max here, the maximum element is on the root node. Then what will you do? If you delete the 8, then same process, you have to delete 8. Now the 8 is going to replace by 2, not to 7. Don't say that 7, because 7 is one level and this 2 is at the second level. This is this level. This is level. This is 1. This is 0. 0, 1, 2. So this is the last element. So 8 is going to replace with 2. 8 is going to replace with 2. Then after you have to, first you have to perform swapping, and then after you have to perform deletion. So 8 is going to delete it here. Now you check that 8 is deleted. Now you have this much tree. Now you have only this tree. Now you have only this tree. Now you check that if this tree is following maxi property. Is this tree following maxi property? No, this is not following the maxi property. Then what you do? You have to perform heapify, and in heapify what will you do? You have to take maximum of 5 and 7, and what is that maximum? 7. So this 2 is going to replace by 7. So final tree you will get this one. Again if I say that delete max, maximum is what? 7. Maximum is what? 7. Then what do you do? 7 is going to replace by what? 7 is going to replace by last element. See, this is 0, this is 1, and this is 2. So your last element is 2. So this 7 is going to replace by 2. 7 come here. This 7 is deleted. Now you have only 2, 5. Now tell me, is it following the maxi property? No, this is not following the maxi property. Then what will you do? You perform swapping. After the swapping, you will get this final tree. Again, I am saying that delete the max, because here I am going to perform delete n element. Here I am performing delete n elements, means I am going to delete every element, but every time I am going to delete the maximum one. If I am going to delete every time maximum, it means that you are getting always maximum element. And if you observe that, your first time you are getting first maximum. So first you have deleted 10. Second time you are getting second maximum. Second maximum what was? 9. Third time I say that again delete maximum. So second time maximum element what you get? That 8 you get that. Fourth time I say that again delete maximum. So fourth time what you are getting? 7 you are getting. So fifth time I am saying that again delete the maximum. Your fifth element is also 5. If you delete the maximum, this 5 you are getting that. So here you are getting 5. If I say that delete 6th time, delete max again. So if you delete the 6th time max, that you are getting the this 2. And this, if you observe it here, what you are getting, that 10, 9, 8, 7, 5, 2, and this is nothing but a decreasing order. This is nothing but a decreasing order. First maximum is the root node. You are always deleting the root node because this is max heap. Opposite you do, that will be the mean heap. So max heap is giving the decreasing order. If you do with the mean heap, you will get the increasing order. Right, you will get the increasing order. I will also explain one more thing, is that here I have, every time I have explained the root node, I will going to explain another. There I am going to explain the random element. So don't be confused that I am always going to delete the root node then follow the same procedure. So here what I am going to delete, here I am going to randomly, here this tree is given and this tree is nothing but a max heap. This is max heap already given, max heap is given already. Now here I am not always here, now here I am not deleting the root node. Randomly they will give you some array, like they will ask you to delete, sometimes they will ask you to delete a 4. They will ask you to delete 4. So simply you so they will ask you to delete the 4 and they will ask you to delete to 3. They will ask you to delete 3 and 4 and 3. So no, I'm assuming that 3, 4, so it better, because this is already 3. So if I say that delete 3, so if I'm saying going to delete 3, the first step, what is my first step? First step is that perform swapping. Second is that delete the last element. So 3 is going to swap with what? The last element. Your last element is what? 5. So 5 came here and 3 came here, and after the swapping, the 3 is going to delete it. 3 is going to delete it. So here I am performing deletion. Look at that. So here in this step perform replacement. In this step I have deleted, and in this step you will get again heapify. After the performance after the performing the heapify method, again you will get the maxim. Again you will get the maxim. So here this 3 is deleted, and he after the deletion you have performed the heapify. I perform the heapify. I have checked that it is following the property or not. Yes, this is following. This is following. It is following. Yes, it's also following. Is it also following? Right. So this is done. 3 is deleted now. Now I said that also delete 4. Right. If I am going to delete 4, can you simply delete 4? No, this is not. Don't say that this is the leaf node, so simply will delete. No, here also 3 step you have to follow. This 4 is going to replace by 2. This 4 will come here. 4 will come here, right? Now you delete this 4. Now you delete the 4, and now delete element is deleted. Now check that is it following the property. Is 5 greater than 1 and 2? Yes, true. This is 7 is the leaf node, no problem. Is 9 greater than 5 and 7? Yes, true. So now is the max heap. So do remember, even the leaf node, still you have to follow the same thing. You have to follow same thing. First swapping, then after deletion, and third what you have to do, check that it is following the heap property or not. If it is not following, then do perform heapify. Right. Now I'm going to explain on the main heap. Same thing I have already explained. Previously I am deleting every time maximum element. Now I am going to delete the every time minimum element. So here this is my graph. This is my mean heap. Here I am performing the deletion operation on the mean heap. So this is my mean heap. This is my mean heap. Now I am going to delete the minimum element. And I have already said that in the mean heap the root will be always the minimum. So if I delete the 2, if I delete the 2, 2 is going to replace by what? 2 is here. So 2 is going to replace by the last element. Last element is what? 9. So 2 is replaced here. And now what you have to do? You have to perform what? You have to first you have to replace, and then third what you have to do? Delete that, and fourth you have to check that it is following the mini property. Is it following the mini property? No, it's not following. Root is greater than, and that's not true. So you have to perform heapify. After the heapify you will get this tree. After the heapify you will get this final tree. Again here if I say that delete 5, delete the minimum. So 5 is going to replace by what? 10. The 5 is going to replace by 10. So this is replaced by 10, and then you have to delete 5, and then next what you have to do? Perform heapify, and after the performance of heapify you will get this final tree. You will get this final tree. Same you have to do here. Same you have to do after the heapify, this will be the final tree. This will be the final tree. Now if I say that delete the delete the what you have to delete here. Here 7 is in the root, no? Yes, 7 is the root. Then if I say that delete the 7, what you have to do? 7 is replace. 7 is here. 7 is replaced with the 9. 7 is replaced with the 9, and then you have to delete the 7, and then perform heapify. After the heapify you will get this tree, right? You will get this tree. You will get this tree, and then you perform heapify. Final tree you will get this one. If you delete the 8, if you here delete the 8, 8 is going to replace by what? It is going to replace by 10. Don't say 9. 8 is going to replace by 10. So 10 will come here, it will come here. Now delete the 8. Now deleted 8 here, and after the deletion you will get this tree. Now tell me, is it following the mean heap property? Not following. Then do swapping. Final tree you will get it here. Again I say that delete the minimum. 9 you have to delete. After the 9 if you delete the 9, the 9 is going to swap with 10. So 10 came there, 9 will come there, and delete the 9. Now there is a single element 10 now. Then there is no need to check here it's following mean heap property or not, right? And that the time complexity of the time complexity of the n element deletion is nothing but a n log n, because in every deletion you are checking what, you are performing heapify method, you are performing heapify for every deletion. So you are deleting here n elements, so n log n, and in height time, the whatever the time of third height of the tree, that much time you are wasting here. So that's the thing, the time complexity of this deletion operation of min heap or max heap, the time complexity is order of n log n. So I have also shown that in max heap, if you always delete the maximum element, means always delete the root node, that will give you the decreasing order, and in min heap, if you always delete the minimum element, you will get the increasing order. That's all about that heap deletion, min heap deletion and max heap deletion. Thank you for watching my video.